Welcome to Copernicus AI, Frontiers of Science. I'm Matilda, and today we're diving into recent breakthroughs in cancer immunotherapy. Adam, what makes this research so revolutionary?
Thanks, Matilda. We're seeing exciting advances on multiple fronts. One particularly promising area is the application of artificial intelligence. For example, Darvish and colleagues published a paper on Kharkiv titled AI-Enabled Lung Cancer Prognosis. Their work explores how AI can significantly improve the accuracy of lung cancer prognosis, which is crucial for personalized treatment plans.
That sounds incredible. How does AI improve the prognosis compared to traditional methods?
Well, traditional methods often rely on limited data points. What Darvish and the team have shown is that AI can integrate vast amounts of data, including imaging and genomic information, to identify patterns that might be missed by the human eye. This allows for a more nuanced and potentially earlier prediction of disease progression.
So, it's about sifting through a larger and more complex data set. Are there other areas where AI is making a difference in cancer research?
Absolutely. There's also research exploring the use of nanorobots for targeted drug delivery. Shahab Kavousinejad, in a recent paper on Archive called Simulation of Nanorobots with Artificial Intelligence and Reinforcement Learning for Advanced Cancer Cell Detection and Tracking, investigates how AI can guide nanorobots to precisely target and destroy cancer cells, minimizing damage to healthy tissue.
Nanorobots guided by AI. That sounds like something out of science fiction. What are the practical hurdles to overcome before this becomes a reality?
The challenges are significant. We need to refine the AI algorithms to ensure accurate navigation within the body, improve the biocompatibility of the nanorobots, and scale up production. But the potential benefits, more effective and less toxic cancer treatments, are driving significant research efforts.
It's amazing how different fields are converging. Are there other angles to these immunotherapy breakthroughs?
Yes. Another interesting area is explored in the work by Hasna Akil and Nadia Idrissi Fatmi, titled A Mathematical Model of Breast Cancer, ER+, with Excess Estrogen, Mixed Treatments Using Ketogenic Diet, Endocrine Therapy, and Immunotherapy. This paper looks at combining different treatment modalities, including dietary interventions like the ketogenic diet, with immunotherapy, based on a mathematical model.
A ketogenic diet as part of cancer treatment? That's a surprising combination.
It is. But the idea is that the ketogenic diet can alter the metabolic environment of cancer cells, making them more vulnerable to other treatments. This multi-pronged approach is gaining traction as we realize cancer is not just one disease, but many, each requiring a tailored strategy.
It seems like the trend is moving towards highly personalized and integrated treatments. What about understanding the fundamental biology of cancer itself?
Definitely crucial. Werner, in his paper Cancer Networks, A General Theoretical and Computational Framework for Understanding Cancer, proposes a network-based approach to understand cancer as a dysregulation of developmental control networks. This allows us to see how different genes and proteins interact to drive cancer development.
So, instead of looking at individual genes, you're looking at the whole system. That's a huge shift in perspective.
Exactly. By understanding these networks, we can potentially identify new targets for therapies that disrupt the underlying mechanisms of cancer.
It seems like these breakthroughs are paving the way for a more precise and effective approach to cancer treatment. What do you think are the biggest challenges that lie ahead?
One of the biggest challenges is translating these discoveries into real-world clinical applications. We need more clinical trials to validate the effectiveness of these new approaches and to identify the right patients for each treatment. Also, the cost of these personalized therapies can be prohibitive, so we need to find ways to make them more accessible.
Thank you, Adam, for breaking down this groundbreaking research. It sounds like we're on the cusp of a new era in cancer treatment, one that is driven by AI, nanorobots, and a deeper understanding of the fundamental biology of the disease.
My pleasure, Matilda. The future of cancer treatment is looking brighter than ever thanks to these exciting advances.